In math, we mostly prefer to deal with plots because they give a better representation of the information. One of these important plots is the Box and Whisker Plot. This plot is a way to display data that uses quartiles, the first, the second, the third, and the minimum and maximum values of a set. How can we construct a Box and Whisker Plot? Let's learn now. We will study how to construct a Box and Whisker Plot for two cases. When you have a set of an odd number of values and when you have a set of an even number of values. This set here contains 11 numbers and this is an odd number. Firstly, to be able to find the median, we need to order these values from least to greatest or in an ascending way. 3, 5, 5, 6, 9, 12, 15, 17, 20, 23, and 25. As we learned before, to find the median, we cancel out one value from each side at a time. If we cancel out these, 12 is left. So 12 is the median. Now, 12 divides the set to two equal parts. We have one part to the left and one part to the right. For this part, we will find the median. If we cancel out one value from each side, we get 5. This is Q1 and the median here is Q2. If we find the median of these values, it is 20 because this is the value in the middle. So this is Q3. The minimum value is 3 and the maximum value is 25. You need to make sure that the minimum and maximum values are not outliers. If they are outliers, we don't include them in the box plot, but we're not going to study this now. To make the box plot, we draw a number line. The minimum is 3 and the maximum is 25, so let's start at 0 with a step of 5, 10, 15, 20, 25, and 30. The minimum value is 3, it's almost here. The maximum value is 25, it is here. The first quartile is 5, it's exactly here. The second quartile is 12, right after the 10. The third quartile is 20. Then we make the box by connecting the quartiles, and then we connect the minimum and maximum values. This is the minimum, this is the maximum value, this is Q1, Q2, and this is Q3. To find the interquartile range, we subtract Q3 minus Q1, or 20 minus 5, which is 15. The range is the maximum and the minimum, and make sure that you differentiate between the interquartile range and the range. The range is 25 minus 3, or 22. The range and the interquartile range represent how wide the distribution of data is. Now, this is another case. These are 10 numbers, and this is an even number of values. Again, to find the median, we need to order them. 3, 5, 6, 15, 17, 20, and 25. So the median is 13.5, which is between 12 and 15. Now we need to find the median of this set, which is 6. And this is Q1, the first quartile. This is here, the second quartile. And the median of this set is 20. This is Q3, or 20. Again, we make a number line. The numbers are between 3 and 25. This is the minimum. and this is the maximum value. So we start from 0, 5, 10, 15, and 30. The minimum is almost here, 3. The maximum is exactly 25. The first quartile is 6, right after the 5. The second quartile is 13.5. It's between 10 and 15. It's more than half of the distance here. And the third quartile is 20. Again, we connect the quartiles. Then we connect them with the minimum and maximum. This is Q1, this is Q2, and this is Q3. The range is 25 minus 3 or 22. And the interquartile range is Q3 minus Q1 or 20 minus 6, which is 14.